So let's go back to this electromagnetic spectrum as a whole. So probably the best way, in my opinion, the best way to understand the electromagnetic spectrum in terms of how it impacts you is, what form of electromagnetic radiation hurts you? Because I think people understand when something hurts you. So when you look at the spectrum, you've got gamma rays all the way through radio frequencies. In the middle, you have the visible spectrum. So that we understand this, your eyes pick up the visible spectrum. That's all that your eyes can pick up. So your eyes are receivers that pick up radiation in the visible spectrum. And that kind of radiation has what's called a wavelength. It's literally a wave that travels through the air. It looks like this. It goes up and down, just like this. And your retina on the back of your eye, inside your eye, all the way in the back, and that's connected to a nerve that goes to your brain, that picks up the radiation from visible light. That's what your eyes can pick up, okay? Now, that's a very, very small part of this entire electromagnetic spectrum. This electromagnetic radiation, which we call visible light, doesn't hurt you. If you don't have it going into your eyes, you can't see, okay? So when someone's blind, it's not that the radiation is bad, is that your eyes are bad. Something's wrong with your eyeballs they're not able to absorb that energy to process that information into your eyes. So the wavelength is literally a wave of energy that goes like this, and the distance that wave goes from top to top is the wavelength, and it is a length. Now, if you take a look at this chart right here, it shows that it's within 1 × 10⁻⁶ to -7 of a meter. This is a meter. This is about 1,000,000 times smaller than that, and that's what your eyes pick up, okay? Now, you also pick up infrared, and you sense infrared with your skin. Your skin can sense infrared. Your eyes don't pick up infrared. Your skin picks it up, and we call that heat. So when you lack infrared radiation, you're cold. That's how it feels, okay? That's how it works. All the other forms of electromagnetic radiation, you cannot notice because your body is not able to pick that up. Animals that are nocturnal, animals that move around at night, that can see in the dark, can see in the infrared, okay? So that's why cats can see in the dark, and animals that see in the dark, owls and mice and so on, can see in the dark. We can't because we don't see in the infrared. They actually see a little bit more in the infrared. All the other parts of the spectrum, we cannot see. We cannot notice. When you get an X-ray, you don't feel the X-rays hitting you. You have no sense of it whatsoever. When the ultraviolet radiation hits you from the sun, you don't feel the ultraviolet radiation hitting you that tans your body. You don't feel that. You feel the infrared and you see the visible, okay? So the X-ray, gamma ray, the ultraviolet, if you look at the wavelength, are smaller and smaller and smaller. When you go to the infrared and the radio frequencies, they're bigger and bigger and bigger. So that's a big difference between all the different forms of electromagnetic radiation, okay? Now, if you have a wave that's moving like this, and all of them move like that, how is one different from another? Well, what we can do is look at the 4 characteristics of waves, which are wavelength, frequency, speed, and amplitude. And those are the 4 things we'll talk about in the next video.